So I usually set myself up a little table for these. But first thing I'm going to do is find the critical values. I'm going to write down my interval just so I keep it in mind. So I'm only interested in stuff that's happening between 0 and 4. My function is given. I'm going to go ahead and just write down the derivative of it. Derivative of 5 is 0. Derivative of 54x. Minus 3 falls down, times 2 is 6 squared. So I'm going to set that equal to 0. So that means 6x squared is equal to 54. So x squared is equal to 9. So x is plus or minus 3. Minus 3 does not live in the interval, but 3 does. So I'm going to test 0, 3, and 4. Good job for the table function on the calculator. Let's quit out of that table, edit my function, clear out the old thing, and we'll put in 5 plus 54x minus 2x to the third, not second, x to the third. Okay. And then I want to plug in 0, 3, and 4. 5, 113, and 93. So I choose the smallest and the biggest y or f of x value. So it has an absolute min of 5 when x equals 0, or at the ordered pair 0, 5. And we have an absolute max. The absolute maximum value is 113 when x equals 3, so it's the ordered pair 3, 113. Okay, I think I will leave 50 for you to do. I'll do number 54. Hopefully I'll leave myself enough room for 50. So 54 f of x is x over x squared minus x plus 1. And we're looking at it from 0 to 3. Well, that denominator is never going to be equal to 0, so I won't have to worry about things that are not in the domain. It's defined everywhere. Low, high, the quotient will try. Low, D, high, less high, D, low. Oh, low times low. Now let's simplify stuff. X squared minus x plus 1 minus x times 2x minus x times minus 1. And combining stuff, I have an x squared minus x squared minus 2x squared, which means minus x squared, I have an x minus x plus x. So x squared minus x plus 1 squared. So if I set this numerator equal to 0, because the only way a fraction can be 0 is if the numerator is equal to 0 and the denominator is not equal to 0. So negative x squared plus 1 equals 0 means that x squared has to be equal to 1. So x is equal to plus or minus 1. Only 1 lives between 0 and 3. Back to the old calculator. I'm not going to make you watch me plug these in. I'll plug that in, I'll go back and do 50, and then I think we'll do 58 and 60 together. Okay, I'll let you check your answers with those. Let's look at number 58. F primed of t is t plus cotangent of t over 2, and we're looking at this on the interval of pi over 4 to 7 pi over 4. And that's f, not f primed. I just copied the function down and differentiate it. F primed is equal to 1 minus derivative of cotangent is negative cosecant squared of t over 2 times the derivative of t over 2, which is a half. 0 is equal to 1 minus half of cosecant squared of t over 2. So let's solve that. Probably the easiest way is to say that 1 is equal to 1/2 of cosecant squared of t over 2. So 2 is equal to cosecant squared of t over 2, just getting rid of that 1/2 by multiplying both sides by 2. So plus or minus the square root of 2 is equal to the cosecant of t over 2. Cosecant is 1 over sine, and sine is equal to square root of 2 over 2 when t over 2 is equal to pi over 4 plus 2 pi n, or 3 pi over 4 plus 2 pi n. Actually, it's plus or minus, so just pi over 4 plus pi times n. Don't even need to divide it up into pieces. So pi over 4 is an endpoint. We're going to be looking at that one already. If I add pi to that, I get about that over 2 part. I had to go back and fix it. So I'm sorry. You're going to need to get out the big honking eraser if you were writing along with me. We want t over 2 is equal to pi over 4 or 3 pi over 4. So t is equal to, multiply both sides by 2. T is equal to pi halves, or 3 pi halves. Now I need to see which of those live between pi over 4 and 7 pi over 4. Now let's see, 7 pi over 4 would be the same as 6 pi over 2, so both of them are going to be in there. So we'll check pi halves, we'll check 3 pi halves, and we'll check 7 pi over 4. I won't make you watch me plug all that in. Started to write them down as exact values, and I thought I can't compare those numbers as exact values. I need decimal points so I can look at them and know which is bigger. So I just wrote down the decimal approximations for each of them. One more. Let's look at number 60. X is equal to x times e to the x over 2. First, d second. Plus second, d first. Not so bad. Factor out e to the x over 2, I'm left with half of x plus 1. Set it equal to 0. E to the x over 2 will never equal 0. Over 2, never. 1/2 x plus 1 equals 0 if 1/2 of x is minus 1. Hopefully you've done this in your head already. X equals -2. And we were looking on the interval from -3 to 1. So -3, -2, 1. Always make your table. Don't try to shortcut. I'm going to pause. Again, I didn't even bother writing down exact answers. I just wrote down the decimal approximations, biggest, littlest. Okay, so just a quick summary. Today we learned about maxes and mins. Important things are critical numbers, are when derivative is 0, or derivative does not exist. We learned the extreme value theorem guarantees us an absolute max and a min on closed interval continuous function. Find the critical values, make a table. I know this was a long video.